this is still 2020 paper, which is GCE, under the topic which is called simple machines. And we know that simple machines are just devices that uses less effort to overcome a larger load. Is that okay? Yes. So they use less effort in order to overcome a larger load. So here, this is a load. What we can see here is called a simple pulley. So a pulley system is the one that is used when you are lifting something. When you are lifting something in this manner. For example, if you got a well in the ride, you are just doing like this. Then the water is coming from the down to up. Yes. So effort is supposed to be less than the load. The load should be larger. So you are using less effort to overcome a larger load. Are we understanding? Yes. Okay, that's a simple machine. So these are called the block and the tackle. Then this one is a tackle. Is that okay? So you have to come to tackle. Alright. So anyway, what we're saying is this is given as 120 as the load, and this is the effort which we are not given. Is that okay? So now they are saying, state the velocity ratio of the pulley. So how do you state the velocity ratio? Anybody? Anybody? Velocity ratio? So velocity ratio is just to count how many tackles are here. 1, 2. How many are they? 2. So the velocity ratio is 2. Now we have to a line few. These lines are 1, 2. So the velocity ratio is the velocity ratio is how much? 2. Okay, good. So question A, we are saying the velocity ratio is 2. Because it's a ratio, so it shouldn't have SI units. Are we following? Yes. Progress to question B. If the efficiency of the pulley is 75%, what is the mechanical advantage? Okay. Is the load not really given? Check the question again. Which is one shan? That is the load. What about the effort? The effort has not been given? Okay, so we can still use this formula, which goes like efficiency equals to mechanical advantage over velocity ratio times 100%. Is that okay? What is our efficiency that has been given? 75. So we are putting 75 here. And then mechanical advantage is what we are looking for. Velocity ratio is 2 and 100. Are we together there? Yes. Okay, so we can actually now just do our math over 1. Then we can multiply mechanical advantage times 100. Right? Then 75 times 2. Right? Are we okay? Yes. Okay, so 75 times 2? 150. Then this one times 100. It's this one and 100. Are we okay? Yes. Okay. And then 75 times 2, which is 150. Then we divide by zare. No, we're not going to by zare. Mechanical advantage goes to how much? 1.5, right? Yes, that is very correct. 1.5. Since it's mechanical advantage, which is a ratio of the load to the effort. Is that okay? So since mechanical advantage is a ratio, then we shall not have SI unit. So mechanical advantage will just be mechanical advantage like that, 1.5. Here velocity ratio will just be 2 without SI unit, because velocity ratio is a ratio of the distance moved by the effort to the distance moved by the load. We know those things. Progress. This is A, B. Now we are going to C. If the load is given as 120, what is the size of the effort? So for this one, we are supposed to use a certain formula, which is which one? Yes, formula for mechanical advantage. See, are we together here? Which we know that mechanical advantage is given by load over shunning. Okay, how much is our mechanical advantage? 1.5. Good. How much is our load? 120. How much is our effort? We do not know. That is the one we are calculating. Will you focus? Then we are saying this times that, right? So we are saying 1.5 efforts. Then 1 times 120? 120. And then we are dividing 1.5 in 120. How much are we getting, ladies and gentlemen? 80 newtons. Good. Because effort is a force. So force is measured in Newton. Yes, that is our C. Then we can possibly deal with our D. So, what work is done by the effort? What work is done by who? What formula do we use when you're calculating work done? What work is done? So we are finding work done. And we know that work done is given by force times distance. Is that okay? Now, what force do they want us to use? They are saying what force is done by who? What work is done by who? So meaning the force that we're going to use is effort force. Are we together? We're going to use 80. So papa F chizafaka for bwanji 80. How much is the distance that was lifted by the load? Effort load lifting 0.5 meters. Remember, this is a Newton. So when you multiply work done 0.5 times 80, 40 Newton meter. What is a Newton meter? A Newton meter makes a joule. Are we together? Yes. So that is how you calculate. Remember, in physics, each calculation carries how many marks? 2. So when you are dealing with that one, you'll be able to see that the first question was just asking you how much the velocity ratio was. You just counted it, how many ropes were there, or how many tackles were there. Is that okay? And then efficiency. They gave us an efficiency of 75, and then we know that we have calculated the velocity ratio to be 2. So if you are taught to find the mechanical advantage, what we did was we used the formula, which is efficiency equals to mechanical advantage over velocity ratio times 100%, where we know that the efficiency has been given to be 75 and the velocity ratio to be 2. You cross multiply this and this will give you 150. 150 you divide it by 100, you get 1.5. That 1.5 is our mechanical advantage. Then we advanced to question C, which they said now calculate the what? The effort, because we do not have the effort here. So basically, we have the load, which is 120. We have the mechanical advantage, which is 1.5. So you just cross multiply this times this times that. So that you get 1.5 equals to 120. You divide by 1.5. You're getting 80 newtons. And I've said that this one is more like force. Are we together? Because it is measured in newtons. So effort is a force. However, the last question was, what is work done by the effort? So the work which was done by the effort, that's why we have used this force as the 80 newtons on this particular last question, which is saying, can get the work done? And we know that work done is a product of force and the distance. And so the force is 80, the distance is 0.5. So 80 times 0.5, you are getting 40 newtons meter, which is a joule. We end there.
Thank you, Mr.
Now you can ask me questions where you're not clear. Somebody for civic education. Allow me to give the receipts, the one.